Today we are going to talk about CloudStack, of course, and KVM. I will share with you how we are doing this in Honolulu and how you can do it to test and to train your team with KVM and CloudStack. This is me. I'm Francisco. In Spain, everybody calls me Paco. It's a very Spanish thing. At Honolulu, we call it Cloud Paradise. I'm a DevOps engineer. I'm actively working with CloudStack and KVM in the last few months. Also, I belong to the DevSecOps chapter lead in Spain. It's a community about DevSecOps. I'm part of the organizing committee of Hack Madrid Percent 27. It's a hacking community in Madrid. So we do a lot of events there. I'm also a cyber volunteer of the National Institute of Cybersecurity of Spain, and also co-founder of XOP Conference. It's a conference focused on everything related to ops, MLOps, XOps, DevOps, DevSecOps. And in November, we have the event. You are all invited. So this is the team involved in all this adventure with CloudStack and KVM. In Honolulu, we have been working with CloudStack since the beginning, but lately this team is the one involved with KVM. Focus on KVM. This is the agenda for today. We will walk through an overview, purpose, and why we chose CloudStack as our orchestrator. A quick comparison between, let's say, the most famous competitor, which is OpenStack. After that, we will dive into the architecture for the lab. We will learn what we need to have a lab with CloudStack and KVM and the main components. After that, we will go to the automation session, and we will learn how to install your KVM host and your CloudStack with Ansible in 3 simple steps. As a takeaway, you will have a demo. You will have to see it later because for reasons of time, it's not possible to do it live. And I will share with you some common issues that we have faced and the best way to fix it. Okay, today we have talked a lot about this, but let's do it quickly. What is CloudStack? CloudStack is an open source platform that allows us to orchestrate compute, storage, network. It's multi-tenancy, and it has a very robust API, and is automation ready. This question is quite important. Why we chose CloudStack at Honolulu? As many of you know, Honolulu is a startup, and for us, it was critical to deliver an MVP, a minimum viable product. And after testing some orchestrators, even OpenStack, we chose CloudStack because it was really fast to make it work. The learning curve was lower than OpenStack. Sorry, OpenStack is really high, the curve of learning, so it was quite difficult to introduce it in the team. CloudStack is simpler. It has fewer moving parts and is easier to onboard the team with this tool. Another reason was that it's production ready. It's completely multi-tenancy, and this was what we were looking for. Very important, at the beginning we were supporting using only XCP-ng as hypervisor, CloudStack supported it and supports almost all the hypervisors. Right now at Honolulu, we are working with XCP-ng, and we are starting the transition to KVM. Another very important reason, mainly for a startup, is the cost-effective. CloudStack is open source, no licenses, no vendor lock-in, and is ready for enterprise use. This is a very quick comparison. Of course, if you go deeper, it will take more than 30 minutes. So I like this picture of the monkey, and it's like Karate Kid style. So, and this will be Cobra Kai. This is very funny. Again, CloudStack is very easy to deploy compared to OpenStack. OpenStack is very complex, and if you don't have a team with experience, it can be like really hard to implement. CloudStack, it has a medium modularity. It means that it has fewer parts, not like OpenStack, which makes it a little bit more complex to implement and to understand. Another thing very important for us is the community. In the open source world, it's really important, the community, because it's the only support you have to fix problems, to understand how things are working for other customers, and is really very important for us. And of course, it's production ready, like OpenStack. But again, what made us choose CloudStack was basically it was easy. It was easy to deploy, easy to onboard the team, and it was very easy to learn. I think that we cannot say about OpenStack. Advantages of having your own local cloud environment deployed with Ansible. We have noticed that Ansible is your best friend with CloudStack. There is a lot of playbooks and roles and documentation that help you to do a lot of things with CloudStack. Local cloud means that you can have it in your own personal computer, of course, if you have enough resources. But keep in mind that at this point, this is not production ready. This lab is only for testing. We will reach that point, but right now we are only using it in development and to test infrastructure as code. One thing very important about what we are going to see today is that with Ansible we can. Is this moving here? Okay. With Ansible, you can spin up several identical environments in 15-20 minutes, which is ideally for testing, for staging, for teaching. Before automating these steps in Honolulu, we used to spend weeks to have a full CloudStack operative environment. And after automated with Ansible, right now only 15-20 minutes. Right now everybody is asking a new environment like as if we're like a coffee, because we can do it really fast. We have tested already Terraform with CloudStack. It works like a charm. I come from AWS world, and I really miss a lot Terraform, and with CloudStack works perfectly. We also are building our images with Packer. Let's say one thing: the plugin for integrating Packer and CloudStack is not fully functional. What we are doing in our case is building in XCP or in KVM host the images with Packer. We upload it to a Nexus, and from there we pull it again with Ansible. We pull it to the respective environment. That is the option that is working better for us. Of course, you can test your CI/CD. You can spin off multiple environments using GitLab CI or whatever CI/CD tool you have, and this makes it very, very easy to manage. The last point is really crucial for us because most of people is not, let's say, has not experience with CloudStack, and having an environment for everyone for training is critical because many of the engineers are coming from Azure or from AWS, and in our case, well, it's very, very important to have this for training. Let's take a look quickly to the architecture of CloudStack. We will have a VM, a virtual machine, where we will have installed the CloudStack management server. There, of course, it's the API endpoint, and all the orchestration of the platform is done there. We have the hypervisors. We can use almost, I think that every hypervisor, but I have used basically KVM and XCP-ng. In those hypervisors, you need to install the CloudStack agent, which is the tool that mediates between CloudStack management server and the hypervisor to manage the resources. And of course, the hypervisors are the ones who run the VMs, the virtual machines. A very important thing that we will be seeing at the end of the presentation are the storage, and the primary storage and the secondary storage. In the primary storage, we save the virtual machine disks, and in the secondary storage, we save the ISOs and the templates. It's really important to make sure that we understand this concept, because the 90% of issues, at least in our experience with CloudStack, are coming from the storage. If the storage is full, we have problems. If the storage is not mounting correctly, we have problems. And sometimes that problems are not so easy to debug, because we receive kind of generic errors, and it's not that easy to troubleshoot. Okay, lab requirements and architecture. The Ansible roles that I will share with you today requires 4 CPUs, 4 GB of RAM. The disk per node can be that or less. It depends on how many machines do you want to run. It's important that at least the CloudStack node has 250 GB, because there, for this example, we will use it as primary storage and secondary storage. Of course, the best choice will be to have it in an NFS, in NetApp or whatever, but for this lab is good enough, and for testing is good enough. We will need Ansible to run the playbook, and even I have written there CloudStack KVM, KMU-libvirt. The same playbook will install all that, so you don't need to care about it. In the control node, we will have CloudStack management server. We will have MySQL, of course. Remember, this is a lab. In a production environment, you can never do this. You need a cluster, and you need your database in another place. We will have in the same machine the NFS, as I told you before, to use as primary and secondary storage. And in the compute nodes, we will have KVM, KMU-libvirt, and CloudStack agent. This is really important, because without CloudStack agent, again, I will share with you a role that installs everything, including CloudStack agent. But keep in mind that if the CloudStack agent is not installed on the host, then the communication will be impossible with CloudStack, and and it's impossible to make it work. Okay, and of course, all nodes needs to be able to communicate to each other. And well, let's leave it here. This can be more and more complicated, but I'm trying to make it simple. Okay, let's do it. Let's install CloudStack in 3 steps. How can we do that? You can clone the repo. Let me move here because otherwise, here, nothing here. You can scan the GitHub repo. Actually, this is the repo we are using inside the company. I have a public, but it's the same. We are using to deploy all our environments. It's good enough. You just need to clone the repo, define the host. You can do it, let's say, more practical and better using the GitLab CI or any CI/CD tool and make it more automated. But basically, you run the playbook, you define the host where you want to install the CloudStack managed server. You can define the MySQL root password. Also, you can define the CloudStack release. In this case, we are using 4.19. And very important, you can define as well which system VM template you want to download. Sometimes people prefer to install 420 for testing, and that's up to you. And the last parameter is really important. Install local DB true. That is going to say that you will install the MySQL in the same host. You can, if you check the repo, you can point to an external database. That will be the best approach in a productive environment, of course. But for this, again, for this example or lab, is good enough. Now, KVM. Let's go with KVM. Again, we have a repo. You can scan it and take a look to it. All the repos are have their own README, so you can learn how to use it. But basically, we are just defining, again, the IP of the host, Cloudware 0, Cloudware gateway, IP address, DNS server, and Cloudware 1 IP. I'm not going to explain this now because the time is not enough, but you will need in each hypervisor at least 2 NICs, and you will need a bridge, Cloudware 0, for, in our case, we use it for management and guest, and Cloudware 1, we use it for storage. Okay, if you already have your network configured, you don't need to, you can just jump to the second alternative, which is the same, Ansible playbook, the host, and the KVM playbook.yaml, and hyphen tags. It looks like 1 tag, but it's 2 hyphens. KVM and cockpit. You can only install KVM, but I recommend to install cockpit. Cockpit is like a web interface to manage your KVM host. It's very, very useful. We use it a lot. You can even test if your host is virtualizing properly, just opening cockpit and launching a virtual machine from there, even if that machine has not connectivity with CloudStack yet. So it's really, really useful. But yes, you can just set hyphen tags and write KVM, and that's it. That will install KVM and all the components, and included the CloudStack agent. Another thing really, really important for us is to keep all the environment sync. I mean, we really need to have all the environment the same templates, the same ISOs is the only way we can make sure that the things we are developing are probably working or are going to work in staging on production environment. This tool is not really a tool. The tool is Ansible, but the collection engine IO CloudStack is fantastic. I mean, you can create a repo. That's why we are doing it right now at Honolulu in your GitLab server, and you can keep consistent templates, offerings, ISOs, networks, and you can keep it versioned, auditable, and automated. All this we are doing it with pipelines, which is fantastic. If someone asks to the DevOps team to create a new environment, it will be 15 minutes. And after that, we will run this playbook, and we will have the same offerings, the same ISOs, the same configuration that we are having in production or in development or in the development environment. It's very easy to define. You only need to write YAMLs. They are really simple. It's really important. Okay, you run Ansible Galaxy collection install. You install the collection. It's important to set the CloudStack environment variable of the CloudStack you are going to choose as target for this configuration. This right now here looks like not so comfortable, but if you put all the CloudStack endpoints in your pipelines, it's much easier. You just run the pipeline, you choose the environment, for example, development, pre-production or production, and then you run it, and that's it. It's all these things, all the things that I'm explaining is better if you use it in pipelines. Otherwise, it will be too difficult to manage. As you can see, for example, in this case, Ubuntu 22.04, I want to pull this template. This is the format, the hypervisor, the KVM. This is the zone. If you want to apply that to all zones, you can do it as well. There is a parameter called, I think, cross zone equal true. The OS type. This is really important. The OS type, make sure that exists in your environment, because sometimes, depending on the version they're using, they don't exist, and then this playbook will fail. But basically, with this configuration, you can keep all the environment completely synced. Okay. Common pitfalls and how to fix them. I'm just going to explain some of them, but I'm pretty sure I have more there, but at the moment I wasn't able to to remember everything. When you install, if you use the Ansible roles that we are talking about, you probably won't have these problems, at least the first one. But in any case, if you get an error 503 on CloudStack UI, most of the time it's problems with the database. Basically, you need to check the etc CloudStack management DB properties config, and then run the command CloudStack setup management again. And that could be the solution for that kind of problem. VM password not working on first boot. This is happening sometimes, but sometimes we have noticed that for any reason the virtual router, the new guys don't know yet what it is, but the virtual router is like the one in charge to injecting the password in the machine. For any reason, is that a router becomes like, I don't know, stuck or whatever, the password VM reset won't work on first boot. And one reason to try this, I mean, you can just create a new isolated network and try. I'm saying this because I was building like many images, many templates, and at the beginning they were failing, and I was thinking that the images were broken or something was wrong with the image, and it wasn't. Very important, in our experience, 90% or more of the problems we have with CloudStack is check storage space. I know this looks like very simple. This looks like, of course, you don't have space. Yes, but 90% you don't know how. If you are using Linux, fantastic, you are going to be happy. But we are using Windows, you are not going to be happy. With Windows, of course, the templates in Linux are maybe 2 gigabytes, but on Windows are 20, and it's easy when you run the role that import the templates to run out of space. It's really simple. You don't know, but you don't notice, but it's like you can have a terabyte, and minutes later you have 50 gigabytes. So keep in mind that the storage is a very important point to take into account. Another problem with KVM host is sometimes it gets not detected. This seems pretty obvious, but yes, you need to confirm that libvirt is active and running. Another way to test this is with Cockpit. I was talking before about that. You can launch a machine from there, and if the machine from there is working, then you have an idea where the problem is. Of course, the CloudStack agent has a beautiful big log where you can try to figure out what is going on. But sometimes there are some errors that are so generic that you still, yes, I'm reading the log, but I still don't know. And it's happening very frequently. Another common issue, system VMs won't launch. They're not starting, or they are starting and then stop and start again. Again, very important that the secondary storage is available, you have a space in it, that you have downloaded the correct version of the system template. If the version of the system template is very old regarding the version of the management server, that could be a problem. Another trick when things with system VMs or network are not working properly, you can safely destroy the system VMs and they automatically will create again. Sometimes it happened to us a lot, is the networking engineers are doing some changes on the ground, things stop working, and then the only way to do it fast is just delete the system VMs. They will restart with the new configuration that you didn't know that your colleague was changing, and this could be a good solution. We have had along our path with CloudStack many generic capacity errors, and sometimes you have no idea because it's only saying generic capacity error and you don't have much info about it. But after digging and digging, we notice again that the primary storage and the secondary storage are crucial. If you have problem with those, then everything could fail. The original picture is a dog sitting there. We have CloudStack. This is our daily basis. Basically, because we are a startup, we are like the Flash running. The train is after us, and we need to be able to fix things in no more than 1 or 2 days, and sometimes it's like this. You need to take a coffee and, okay, everything is burning, but this is fine. We can make it. It's our daily basis. I don't know if we have time.
I think it's time.
We have time. Let's see now. Maybe we have time to see the demo. I don't know. Possibly. So this is the Cloud Lab Arsenal. We will spend here a few minutes because I need to explain many things. The stable installers are those CloudStack installer and KVM installer. Of course, those installers, those roles can be improved in many ways. From in this moment, in Honolulu in production, that's working. So I can say that that's working, so it's fine. We are usually improving these roles, but well, those are perfectly usable. In testing phase, for this demo, this demonstration, you can see it there, or maybe we have time, we can see it together. I use background to create 2 virtual machines to install automatically everything with Ansible, and you can have your environment just like this, very, very quickly. Why that lab is still in testing phase? It's still in testing phase because I want to introduce another feature that will be the creation of the zone automatically. Right now, that background, what it does is to apply those installer, create 2 virtual machines, interconnect them, and that's it. That's why are in testing phase. The other repo in testing phase is CloudStack Lab AWS. Yes, AWS, call me crazy. But sometimes for many people it's easy to use, this one is Terraform, to use Terraform apply and have everything done in AWS, at least for a testing or for a quick test, that to ask to the storage team to create a new NFS for my new environment, then the infrastructure team needs to create the 2 virtual machines, then it's really, really complex, and this is an approach to make it easier. This is still in testing phase. I should have put it here like a big red, but be careful because in AWS, nested virtualization is not enabled by default. Then you need to select an instance type, which is a bare metal, which is really, really, really expensive. So keep that in mind if you want to test that option. Another thing that has helped us a lot is the community. If you are not subscribed, please do it. The CloudStack mailing list user is the best thing you will do today, probably. When you have critical errors, errors that nobody knows, that Google does know, that ChatGPT doesn't know, and even if you go to CloudStack documentation, you can find a solution. The only people that that help you are you guys, the community, and I truly recommend you to subscribe. I don't know how much time I have. None. Okay. Again, watch the demo there because I know that time is not enough. Thank you very much.